Hey guys, this is Carl, and this is just kind of going over, just want to give you kind of a broader sense of calculating confidence intervals, and we'll take this example that's slightly related to homework problem. In country A, the vast majority, 90% of companies in the chemical industry are ISO 14001 certified. This is an international standard for environmental management systems. An environmental group wished to estimate the percentage of countries B's chemical companies that are ISO 14001 certified. Of the 500 chemical companies sampled, 360 are certified. So what we're going to get at is eventually is the 99% confidence interval. But first, we have to do it through a series of steps, and we're kind of starting here, similar to your homework from this past week, talking about the true proportion. What does that mean? It's almost similar to probability, where you're taking the 360, which relates to here, certified, divided by n, which is the sample size in this case. And so as you see here, n, the sample. So 360 divided by 500 is 0.72, and that's your true proportion. But also part of our confidence interval relates to these q and n hats, q and p hats rather. So to calculate q hat, it's 1 minus this p. So as you can see, this and this, it's the same. It's just kind of a different denotation related to it. It's 1 minus this, which gets you 0.28. So these two right here. Moving on to step 3, we want to calculate n times p and n times q. And what does that mean? What is the n? As we've mentioned before, n is the sample size. So that's all you're doing when you calculate here is 500 times 0.7, 500 times 0.8. It gives you 360, and it gives you 140. Now, the next step after that relates to the z-value, or the normal distribution. Now, it's important to note that your z-value will differ depending on your level of confidence. And remember, confidence interval, when you say 99% confidence interval, just as a rule of thumb, in hypothesis testing specifically, when you want to calculate alpha related to that, it's 1 minus this, whatever your confidence interval is. So in sense of this, alpha is 1 minus 0.99 or 0.01. If it's 95%, alpha equals 0.05. So you get the gist of that as a future reference. But for our 99% confidence interval, our z-value from our table is 2.576. And so we're getting close to having all the information we need. So we go down here, step 5, calculate the lower bound of the 99% using the above values. So your lower bound equals p minus c times the standard error of p. So in lower bound and upper bound, what does that mean? Well, the lower and upper bounds means, with respect to confidence interval, the range, with the lowest value and the highest value, where you express, in this case, 99% confidence that all of your samples, all of your values within the sample will fall in that range. That's really what you're saying holistically with confidence intervals. What interval contains that you're 99% confident contains all the values of the sample. So, in calculating the lower bound, all it is, see p, as we calculate up here, p is 0.72 minus our z, 2.576, times the square root of p times 1 minus the p, which is up here. So p times 1 minus the p divided by n, which is your sample size, 500. This equation is the standard error, or SE, as it's related to here. The SE of p, it's because p is right here. P times 1 minus p. So, or as it's referred to, is Q. And this is just a little bit, just going to give you a sense of how this equation looks. So, and remember your order of operations. It's really important with respect to what do you do first. In this case, remember that the square root takes precedence. You want to complete this formula here, so that allows you to square, followed by multiplying that result by this, and then subtracting from this. So after all that's done for the lower bound, you can see that's 0.668, as you see up here. That's how the formula looks in Excel. It's a little bit unorthodox in Excel in terms of logically putting it out. So step 6, the upper bound, same thing, only difference is minus and plus. It's really your only difference. Same thing, order of operations, it gets you 0.772. So the 99% confidence interval with these conditions is 0.668 and 0.772. What does that mean? In terms of interpretation, that we are confident that 99% of all the values of the sample fall within this range. We hope that this helps. Just let us know if you have any questions along the way. Thanks so much. Bye-bye.